Alright, let's start. So I have to put all of them together. And then remove the duplicates. Let's see if there are any ends on this one. I don't know how to specify the number of arrays that it's gonna give me. There we go. For a better idea here, instead of doing this, when you removes the last time. Yeah, dot reduce would be interesting, I think. How can I say if number equals the last one, the previous one? That's what I'm thinking about. I think it closed that window. Maybe you use a loop, this is easier. But I wanna know how to do it with filter also. You don't wanna be using a loop every time. How can I see the last one? Last frame. Maybe that doesn't make sense. think this might be the way. If they have different values, remove them. The duplicate item is the item whose its index is different from its index of value. This is the one. There we go. Nice. Nested for loop, then use it includes here. This concatenates all of them to this new array. Then use this filter same way that I did. If I understand correctly, if the index of the number that's evaluating is different than the actual index, it means that it's a duplicate. So we're only gonna return the first time that they're equal, which is the first position that that number is encountered. it's gonna create a new array based on that, which in my case is the same one, because I made r equals r dot filter. Oi. Just a sec. Shit. No. Is this muted? Probably not. I'll be right back. Okay. Feels good. Should get it right. Feels good. And this uses the set method from the, as the other page was saying, which I never never seen before. First use concat with an empty array as a starting point with this spread operator to create an array out of the arguments object and to flatten it at the same time. Then we use the new set object to store only unique values. So I guess that this is the purpose of this challenge, to get people familiar with set. Start unique values. I don't know what is this flat thing. No. Same as solution 5, but using the flat array method. I don't think there is a... Oh, here it is. I'm gonna close this one. Creates a new array, false subarray, elements concatenated into it recursively. Up to the specified depth. Also, it makes a nested array into a single array. Up to the depth you specify. So if there are multiple arrays inside of the arrays and you want to remove them all, just put a high depth. I don't know if I'm saying this the right way. Depth. Okay. Let's watch this guy. See how he did it.
Hello friends, welcome back. Today we're going to do the sorted union.
Skip the intro.
And then I plus equals 1. And now if we console.log our object argument values at position I, we're going to get, oh, let's get rid of this one. Oh, we need to do this one dot length. I'm going to expand this so it's a little bit clearer. Then we're passing it through. And so our object values is 1, 3, 2, 1, 3, 2, but we're doing it in order now. So we've got these ones, we're iterating through them. And we don't need to console log the result right now. So yeah, object.values. Now, having this in here, I just want to refactor this now because this is having all this object.values is annoying. So we want to say let value.
I wonder if I can make a bunch of for loops with the same variable every time, or if that's not appropriate. Because every time that I create a for loop, even if they are not nested, especially if they're not nested, I'm using a different variable, but I'm not sure if it's better to use I every single time, and then the computer is gonna reassign the value of I after it goes through a loop, one loop after the other.
Is equal the object.values. And then in here we can say values, and then in here we can say values. Cool. And so now we're working through each of these. And what we want to do now is iterate through them. We want to make it a nested loop, right? Because we want to be able to go through this one, and then this one, and then this one. So we're going to do a nested loop. So we'll go for let j equal 0. J is less than values at ij. And then j plus equals 1. And now we can console.log all values at ij. Oh, this needs to be dot length. And we can console log the values at ij. And oh, this just needs to be at I. Okay, so now instead of console logging here, I'm going to undo that one. And now what we're doing is we're just going 1, 3, 2, 5, 2, 1, 3, 2, 5, 2. So we're going through and it's printing out the numbers in order. So yeah. Let's see here. What can I say about this? Instead of saying values at I, we could say array. Nah, we'll just leave it like that for now. So now that we're iterating through, well, we know our final collection. So what do we want to do? We want to write the value to the final collection if it's not part of it, right? So values at ij, initially it's 1. If the final collection, does the final collection have an index of the values at ij? So each of these are rendering out -1, right? Because the final collection doesn't have anything in it. And so we can use this as our conditional statement. So if the final collection index of values is equal to -1, meaning it's not there, it's not part of the results array, then we want to do the final collection dot push the values. Oh, and now we want to just console log the result. Okay, 1, 3, 2, 5, 4. 1, 3, 2, 5, 4. This will probably pass the test. Awesome. Now let's think about refactoring, right? It always makes sense to refactor. We could call this our our groups. We could let this one be our group of groups, and we can set that equal to values at I. Group of groups. That makes it so that it's more explicit, right? If we were to console.log our group of groups, we would see that this is a group of groups, right? Group of groups. So that makes it so that I think that it's a little bit more explicit. We've got even if I guess if there was only one array in here, we would only have one group of groups. So yeah, I think that makes sense. I like to do this because I think that it makes values at I and j. This doesn't make a lot of sense to me. So like if you're reading through code, sometimes it makes sense to make things a little bit more verbose. People who just like to add like one letter to mean something, it makes it so that the code becomes slightly meaningless to me. So we want to let our individual values that would be equal to our groups of groups at position j, and then instead of saying positions at ij, we can just pass in our individual values. See, and it works exactly the same way, but when you read this code, you're like, okay, final collection, and then we set our values equal to the arguments, the values of the argument being passed in, so we know that it's coming from there, and then we're going to iterate through our values, and we're going to get groups of groups, okay? Those are equal to each of our individual values of our groups, and then we're going to iterate through our groups, so we know we're going through, and we're getting individual values, and then if our final collection has an index of where our individual value is equal to -1, meaning does our final collection not have this, then our final collection, we push in the individual values, and then at the end of everything, we return our final collection, and I think that makes sense. Another thing is we're working with arrays here, right? So we could be doing for each, so instead of saying values.length, we could have the values.for each, and then we could do a function. And then instead of saying setting group of groups here, we could set this here. And then we wouldn't need this guy. And we could pass our for loop into here. Yeah, we'll get rid of this guy. Oops, I want to set this guy here and this guy here. I guess
there. Yeah, yeah. This one I can write it out. I'm not understand. Where the characters, double quote, and truth, and a string to their corresponding HTML entities. I don't know why these are the corresponding HTML entities. Yeah, I don't know. I have no idea how I should do this one. Not even a clue. Maybe it says on the hint. Should separate this string and work with each character to convert the right ones and then join everything back up. So this gives me a hint that I should be using splint. Maybe it's like this. Then I should probably loop this string. Or maybe I can use filter. I think there is a replace thing or erase. Replace is only for strings. So each one of this has a name. Is that correct? Now here's a LT and here. Oh yeah. Oh, I get it now. So each one has a special thing. Maybe I'll use switch instead of if. forgot how to write it. So I think this is the best way to do it. So this syntax is wrong. What's wrong with this? So this is a special curve. Don't understand. Maybe if is better. Or maybe if I put it on strings. Maybe I create a new array. Yeah. The string is square. Can I really do this? Quotes inside quotes. don't think this is the right way to do this. I was missing the thing. Should be right. Nice. Let's go. I should use strings if I want to use case. Instead of if.
Hello friends, welcome back. Today we're going to convert HTML entities. Convert the characters ampersand, less than, greater than, and then quotes, a double quote, with and the apostrophe and a string to the corresponding HTML entities. Remember to use read, search, ask if you get stuck. Try to pair program, write your own code. Okay, so convert HTML, Dolce and Gabbana should return Dolce amped with a semicolon Gabbana. Okay, so right now, what's it doing? Well, let's say let the result equal to that, and then we're going to console.log the result. so we can see what's happening. Right now, it's just returning that. So what do we need to do? We need to maybe iterate through the string and say if we see an ampersand, then we write this amped here. The same thing. We want to be able to identify these guys and this guy. And then we want to convert HTML stuff in quotation marks. So here we're getting a string with quotation marks in it. We want to return that with this character, and we want to do that. So this should just return nothing but these guys. Okay, so we're basically going to be doing a lot of string manipulation. So yeah, just like the last one, what we could do is do a function, like a function of convert character. And then we'll just pass in, and we're going to be passing in a letter, right? And so what we can say is if the letter is equal to an ampersand, then we're going to return ampersand stuff at amp. We're going to return this. Cool. And then else if the letter is equal to a lowercase, we want to return this guy. And now I'm just going to copy this. Now we need to add to a greater than sign, right? And then the greater than sign is this guy. And then what else? Less than greater than. If it's a single quote, I think we got to do it like this in escape quote. Maybe. Yeah, maybe like that. Single quotes and then a double quote inside of it. That'll get us an apostrophe. Or no, that'll get us a double quote. And if we do a double quote, what do we want? Do we have it in our examples here? Oh yeah, under quotation marks. So we want to replace it with this guy. And then what happens if we have the opposite of this? With a apostrophe. Schindler's List. Oh, that's sad. We want to pass in this guy. Okay, so now we can be like, okay, so string. We want to return the string. Well, we can iterate through the string, right? Now this function doesn't even need to be in here, so I'm just going to take it out for now and put it up here because I think it's better to have it so that we can convert the character anywhere in this. This function will still be allowed to be used in here, so that's what we're going to do. And now what can we do for the string? Well, we could iterate through it, right? Just so go for, we're going to let I equal 0. I is less than string.length. I plus equals 1. And where you've got an iteration happening. And if we go string at I, if we were to console.log that, we're iterating through each element of the string, right? So D, O, L, C. And now we can say, well, what are our characters that we want to check for? Characters, so we want to say let characters to check for. We're going to make that equal to an array. And we can set this equal to, well, instead of doing it, yeah, we can do it, I'll do it this way. We can go ampersand like that. Instead of console logging here, yeah, I'm going to get rid of that for now. We can do an ampersand, less than sign, a greater than sign, but that one, and then put the apostrophe in there as well. And now we have our characters in there. Cool. So now if we're console logging at the string at position I, well, we could say, so here we're going through each one, and at one point the ampersand is the one that we're selecting, right? And so if we did characters to check for dot index of string at position I, well, then we're going to see almost all of these don't require any editing. But here we have the ampersand, which is our initial one, so our value is not -1. So now we can alter the string based on that. Maybe not alter the string because that's going to change the global variable, but yeah. So for now, what we could do is we know what position this is in, right? I'm console logging it here. If we go I, we know that it's actually at position 6 is where we want to change. So what we could do is say if characters to check for is not equal to -1, we're going to console.log the I. So here we're getting 6, right? Because we're at position 6. So what we could do is console log the string dot slice from 0 to index. That's going to get us dolce, and my guess is a space as well. Yes, there's a space in there as well. And then what we can do is add in there our convert character, and we convert this. I'm going to move this over so we have more space. Letter's not defined, but string at position I is. And now we've shifted this so that, is it supposed to be an ampersand? The ampersand? Yeah, it has an ampersand in it. Okay, so we've got the amp in there. But then what we need to do is add the space and Gabbana at the end as well. And so what we can do is, I kind of do these long string interpolations like this. And then we can add to it, oh no, we're still doing the console log. And then we'll add to it the string.slice, I think I. Yeah, and so string.slice at I gives us the rest of the results, right? So dolce space and Gabbana, and then we tab in here. Oh, but we don't want this ampersand in there, so what do we do? I plus 1. Cool, and now we've converted this. But we don't want to do it in a console.log fashion, right? We just want to make, we want to save it as a variable, right? So our result is equal to, no, we can just, how should I do it? Well, I mean, the way to do it simply would be to do string is equal to that, and then get rid of this. Just to make this more explicit, I just want to show this all in one line. So I'm just interpolating the string altogether. And so now that we set string equal to there, we can run the test and see if it passes. Okay, everything passes. Why is that? Because we're using this exterior convert character string, and so that if we pass in anything, like for example, stuff in quotation marks, then this converts, we pass in, if we were to console.log the string at position I, you can see that it's passing in these quotation marks. So we could actually extract this. So we could say let symbol to convert is equal to the string at that position, and then we can pass the symbol to convert in here. That might make the code a little bit might make the code a little easier to read. Sometimes I like to do string interpolation like this. And so yeah, and now we've converted this so that it's got this. And in HTML, you can you'll see a lot of like WordPress websites and things like that use this in the back end to show those symbols. So yeah, I think that's good to go. String.length, characters to check for, return this guy. Usually I like to do my spacing like this. Yeah, we could just extract this into its own separate function of like adjust the string, but I don't know that that's necessary. I think that this, we convert to HTML by passing in strings. We convert characters by passing them into here. Yeah, don't know what else to say. Run the test and they pass. Hope you guys enjoyed this one, and we'll see you in the next lesson.
In a positive integer num, return all the sum. Return the sum of all odd Fibonacci numbers, or less than or equal to none. So that should be odd Fibonacci's. So first I have to create this sequence from the last number. I think this should create Fibonacci sequence there. Number 4. 1, 2. So it doesn't work. Let's start at 0 here. So 1, 0. Oh. Now I think it works. And should have 2 there, I think. And 4. No, it's not pushing for. Because I shouldn't push for. It goes up to 3 when it's 4. If I just make this equal 0, and do it like this. I don't get it. Why is it? Why is it true first? Oh, because here is already increasing by 1. That's the issue. It's gonna give me no. What's wrong? Infinite loop. I don't understand why this is an infinite loop. The condition is I equals less than or equals number. Maybe now it works. Oh, it's because the variable. No, that doesn't make sense. Because it should overwrite there. I'll be right back. there's an easier way to do this. Just assign a variable here. Maybe the variable needs to be outside of the array. It doesn't change anything. Oh, it's an infinite loop because I started at 0. That's fine. Let's try that again. Now it's missing the, it's supposed to be 3 instead of 4, and it's making 2 plus 4. So the issue is that it's not supposed to add on itself, it's supposed to add on the previous number. I put I equals 1 here. Let's see what happens. How can I say previous number? Maybe I do differently. I start with 1 here. Then instead of pushing That doesn't make sense. Oh, I know what I'm gonna do. First, I'm just gonna push the numbers. One by one. Until it reaches 4. But then if I wanna filter, it's gonna be more complex. That doesn't work. So let me think about this sequence. The sequence is supposed to be every number is gonna be equal to the number plus the previous one. And I think that should work. Why is giving me none, not a number? So this is pushing one by one, which is not what I want. And this is not gonna work as well. Now is the right sequence, but no, here's too far. And it's too far down. It needs to be 3. Now there we go. Now I think it's correct. But it's still not stopping where it should stop. It should stop here. 1, 1, 2, 3, 5, 8. So the condition should be if I less than or equal to sum. This is gonna give me an infinite loop. There we go. Okay, now I think this part is correct. And what should I do next? The first row. Sequence freeze. Given a positive integer num, return the sum of all odd Fibonacci numbers that are less than or equal to num. So now I can use reduce. This takes it's gonna take two numbers, compare them. Undefined. So odd numbers are not divided. It's by 2. I think the reduce is the correct one. But I want this sum. So why this should return 5 not true? The only number that is not divided is true. I understand. Oh no, no I get it. Sorry. You want these numbers, the odd ones. So maybe it is reduced here. This is the sum. I don't get it, and it's giving me it's not a number. Oh, maybe I should make a different variable here. No, still same thing. makes sense.
Essa é OutSystems, a mais completa plataforma de desenvolvimento de aplicações full stack para programadores.
Once again with our array of numbers, let's say we want to calculate the sum of all these numbers in this array. This would be similar to calculating the total cost of all the items in a shopping cart. So each numbers here would represent the price of an item in a shopping cart. Of course, we wouldn't have a negative number there, but you got the point.
I know how to do it using a different variable here and storing the value, but I wanna try to do it with the reduce method, just to learn.
So here's a very simple algorithm for calculating the sum of all the numbers in this array. We start by declaring a variable called sum, and we initialize it to 0. Next, we loop over this array, get each element or each number, and add it to sum. Something like this. For let n of numbers. Now we want to add n to sum. So we can write an expression like this. Sum equals sum plus n. Or a better way is to use the addition assignment operator. So we can exclude the second sum. So this is exactly like the statement we had before. And finally, we display sum on the console. So we get 5. Now there is a cleaner and more elegant way to write the same code using the reduce method in arrays. So all these arrays have this reduce method, and with this method we can reduce all these elements in an array into a single value. That single value can be a number, it can be a string, it can be an object, it can be anything. In this example, we want to reduce all these elements into a single number. That is the sum of all the numbers in this array. So let's see how we can use the reduce method. This method takes a callback function with 2 parameters, accumulator and current value. So here I'm using an arrow function like this. This accumulator parameter here is exactly like the sum we have here. It's something that we initialize, and then this callback function is executed multiple times. Each time, this current value will be set to one element in this array. Okay? So in each call, we want to get this current value and add it to accumulator. So we simply return the sum of accumulator plus current value. Now internally, this reduce method will get this result and store it in the accumulator.
But I don't understand. Why is not giving it? Let's see if this runs. Now it gives me 7. Just the sum of everything. So the issue is the if statement. No.
Later. You'll see that in a second. Now one last thing we need to do here is to initialize this accumulator to 0. So as the second argument to the reduce method, we pass 0. Note that this reduce method has 2 arguments. The first argument is a callback function, and the second argument is the initial value for the accumulator. Finally, we get the result as a single value, in this case, sum. Now we don't need this code anymore. And finally, let's bring this console.log here. Save the changes. You can see we get the same result, 5. But let's see what exactly is happening here. So initially we set accumulator to 0. So I'm going to set a equals 0. In the first round, current value will be set to the first number. So c equals 1. Now we add this together. So we get 1, and a will be set to 1 after this callback function is executed. So as a result, a will be 1. Now in the second round, a is 1. Current value will be set to the second number in this array, so -1. Now once again, we add them together, so a will be 0 after the second call. Now the third call, so a is 0. The current value is going to be set to the third element in this array, so 2. And as a result, a will be 2. And finally, in the last call, we start with a set to 2, and current value will be 3. Okay, so the result will be 5, and that's why we saw 5 on the console. So essentially, with this reduce method, we start with an accumulator, then we loop through this array and convert all these elements into a single value, which is in this case accumulator, or the sum of all the numbers in this array. Now we can make this code even shorter. We can exclude the initialization of the accumulator, and with this, accumulator will be set to the first element. So let me show you what will happen. A will initially be set to 1, and current value will be set to -1. That is exactly like our second call here, right? So as a result, A will be set to 0. Now, in our second round, A will be 0, and current value will be 2, because in the previous call, current value was here, so now we're here. So current value will be 2, and as a result, A will be 2. And finally, in the last call, A will be 2, and current value will be 3, the last element in this array. And once again, we get 5. So if we supply an initial value, we'll have one more call. If we don't, the first element in this array will be used as the initial value. So this is how the reduce method works. And finally, to make this code a little bit shorter, we can get rid of this return keyword because we have a single line and we are simply returning a value. So remove the return, the semicolon, and the curly braces, put everything on a single line like this. So with this single line of code, we reduce the numbers array, and this is how our reduction algorithm works. We simply get the current value and add it to our accumulator. This is far cleaner and more elegant than declaring a sum and then looping over this array like let n of numbers and then add n to the sum. That's a very old way of writing code. Hi guys, thank you for watching my JavaScript tutorial. This tutorial is part of my JavaScript course where you will learn all the essential JavaScript features that every web and mobile application developer must know. If you're an absolute beginner or have some experience in JavaScript and are looking for a fun and in-depth course that teaches you the fundamentals of JavaScript, this course is for you. This course is also packed with tons of exercises that help you master what you learned in the course. In fact, many of these exercises are questions that come up in technical programming interviews. So if you're pursuing a job as a front-end or a back-end developer, or if you simply want to have a more in-depth understanding of JavaScript, I highly encourage you to enroll in the course. For a limited time, you can get this course with a discount using the link in the video description. Click the link to find out more about the course and enroll.
Oh, maybe I can filter first. And then I can use dot reduce. There we go. Okay, I think that's it for today. I'm gonna stop on this one. And then I see the solutions and then I'm done. I don't understand why the reduce didn't work there. With the if statement. Might have to do with the way the value that inputs the value first. Because it can't divide by 2 and see the check for the remaining.
Hello friends, welcome back. Today we are going to sum all odd Fibonacci numbers. Given a position number integer, or given a positive integer n, num, return the sum of all odd Fibonacci numbers that are less than or equal to n for it to num. The first two numbers in the Fibonacci sequence are 1 and 1. Every additional number is the sequence in the sequence is the sum of the two previous numbers. The first
Let's skip the intro.
We're just returning the exact number that we came in with.
And read the solutions here first. So create 2 variables, previous and current. Oh, so it checks first before adding the number to the result. Yeah. Let me just reduce here. Okay.
Yeah, I think a good way to do this would be, well, we need to be we need to have something to start with, right? So let the first two values of Fibonacci sequence, we're going to set that equal to 0 and 1. Cool. So I think, you know, while, and then let's do a, well, let's just go, yeah, we could go, okay, Fibonacci sequence. And then we're going to say the counter is equal to Fibonacci sequence at position Fibonacci sequence dot length and then Fibonacci sequence, well, Fibonacci sequence dot length minus 1 plus Fibonacci sequence dot length, oh, Fibonacci sequence of Fibonacci length minus 1 plus Fibonacci sequence at position Fibonacci sequence dot length.
God damn.
Let's see what happens when we console.log the counter. Counter is not. Oh, we need to say let the counter. Okay, it's not a number. So, well, let's first off try to console log this. Does this turn into a number? Okay, this is. And that's this, the length minus 1. Okay, and then what about minus 2? Would that give us 0? Cool. Okay, so we want to do Fibonacci sequence dot length minus, well, let's start with 2 and then go minus 1. Cool. And so I can get rid of this console log now. I'm going to move this over so we have more of a view of what's going on. And I'm going to tab this out here. So our counter is equal to the Fibonacci sequence, the length minus 2, and the Fibonacci sequence dot length minus 1. So this is right now, Fibonacci sequence, if we were to console.log this, you're going to see that this is equal to 0, and then this one is equal to 1, right? So we've got, let's not do the result. So right now, at -1, we're getting 1, and then at 2, we're getting the position 0 is there. And now what we want to do is say, I think we could go like, while the counter is less than the number, then we want to go Fibonacci sequence dot push. And right now the counter should be 1, right? Yeah. We can get rid of this console log now. The counter is going to be 1, so we're going to push on the new value for the counter. What happens when we get to our result? And I'm going to get rid of all of our console logs except for the result now, so that we can think a little clearly on this. 0, 1. So Fibonacci sequence dot for each, and then here we could go function.
Just push through a new array and then use
even. This is basically how to say if it's even, because like 4 is evenly divisible by 2. 4 modulo 2 is equal to 0. 5 modulo 2 is equal to 1. And so we're like we're only looking for ones that are even. So what we can we're logging the result down here, but we're logging all the odd Fibonacci numbers. And then if you check the sum while we're doing that, so here we got 1, so 0 becomes 1, and then plus 1 is 2, 2 plus 3 is 5, and then 5 is equal to 10. Oh, if I did this console log below this, then we would get the 10 down there, but it happens afterwards. So that was just for illustration purposes. Yeah. Okay, so if we run the test, I think that this will pass. My guess is that the counter should be less than or equal to a number. Okay, that was what it was. So this is probably like a really great, this is a really large Fibonacci number. So how long the rest of our code is. There's probably a way to just do it while we're in the counter here. You know, instead of building the array and then going through this process of summing it up, we could probably just, you know, say the counter, like right now, the sum of Fibonacci numbers is equal. We could say the sum of the Fibonacci numbers is equal to 1, and then we could add that up here. And then, you know, if the counter isn't, then we do the sum of all Fibonacci numbers.
I think the usually start with 0.
Return number. So we actually don't need that secondary iteration, which is going to make our program way faster. If we were doing this to a huge data set, having a while loop that created a big array, and then we went through the array and summed it up with conditional statements, that would be twice as expensive programmatically to do. Than just doing it this way.
That's why they didn't create an array in this solution.
I mean, another thing that we're seeing here is this is a duplicate code, right? And so we could do something like, instead of adding a Fibonacci sequence like this, I'd still say we want it in here, so we could have a function which would be like iterate up Fibonacci sequence. And here we would pass in, we should still call counter just to make it easier for us. And then we could just say return the Fibonacci. Yeah, we just would want to return the Fibonacci sequence here. And then instead of having this written twice, we could just say Fibonacci sequence and then throw in the counter. And then instead of doing this again here, we could write that here. And then we're still doing 1, 3, 5, 7, 2, 1. So we're still getting the right test. Again, I'm just refactoring this code in the hopes of making it a little bit clearer to understand. So we add to the counter. If the counter is odd, we add to the sum, and then we iterate the counter up. And then, therefore, we just keep moving up the function line. So we don't need any spaces up there, and run the test, they pass. Cool, so I was just going into more depth. The initial way that I wrote that would have worked, but programmatically this is more efficient, and I hope that this is a little bit easier to run. Iterate, so when you're reading this code, you're like, okay, the sum of fibs. And also, I don't like that it's called the sum of fibs. It should be the sum of odd Fibonacci sequence numbers. See, this is how I would name this function, because that would make it so it's more clear. When you're reading the thing, you're like, what does this function do? Sum of fibs. Well, that just means, okay, it probably sums up whatever a fib is. But if you say sum of odd Fibonacci sequence numbers, it's like, oh, okay, cool. So we're starting off with the Fibonacci sequence. The sum of the fibs is 1 at the point that we're doing this. Okay, so we've got a counter, and then we're just iterating up the sequence. So what does that mean? Oh, well, iterating up the sequence just means we're taking, the position at like 1, 2 ago, and then 1 ago, and then we're adding those together, and then we're doing that to the counter. It's like, okay, cool. So while the counter is less than the number, well, okay, cool, that number is the one thing that we pass in. Then we add this Fibonacci sequence to the counter. Got it. If the counter is odd, and you could also just extract this. We can make that a function, right? Is odd. It's counter. And then we could just say is odd the counter. So if counter is odd. Somehow that broke. Okay, I'm going to undo that real quick. What was here? If counter modulo 2 is not equal to 0. We want this to return. Oh, I see what we had to do. We had to return it. So I'm just going to redo this. If, and then we want to return.
Yeah, okay. So, yeah, that's it for today. We'll be back another time. So, see you.